Okay, in this section, we're going to review the graphs of sine and cosine. So let's look at these two sinusoidal waves and try to recall which one is sine and cosine. Hopefully you remember that this black one is sine. This is the sine wave. And then the blue one is cosine. So let's talk about a few characteristics of these graphs. So first thing is, let's talk about amplitude. Amplitude is the overall height divided by 2, or kind of if you started from the center of the graph, the middle of the graph, and how high would you go and how low would you go. So for example, let's look at this, let's say this cosine graph. So you can see the middle is right here. So it goes up to 1 and it goes lowest to -1. So this amplitude is 1. Okay, so let me just draw that here. So this part is called the amplitude. All right. The next thing is this thing called period. Period means how long it takes for the graph to repeat itself. So you can see, for example, sometimes it's a little hard to tell what the period is. So what you can do is you look for the characteristic parts of the graph. So for example, if you look at this cosine graph, you can see that the top is here, and then you look for the next time the top of the graph appears again, which is here. So then this part, this length, is 1 period. Oops. In this case, you can see that this length here is 2 pi. All right. And you can see also the difference between sine and cosine. They're essentially the same graph. They're just kind of offset by a little bit. You can see that it is, we'll talk about that later, but this is offset by pi over 2. Now, let's take a look here. All the sinusoids have their own transformation equations as well, just like all the other parent functions. It's pretty much the same, except you can see that there is this B, C, D that was not used before, but it's the same idea anyways, and we'll go through that. All right, first, let's talk about amplitude. How do you figure out how high or how low the graph will go? That has to do with A, which is absolute value of A. What about the period? You can find the period, or the length of the period, from this formula, 2 pi over absolute value of B. B is the number that's multiplied to x. The key is multiplied to x. And then we'll see how to do that in a few examples later. Frequency is going to be the reciprocal of period. So just take that formula and flip it. Phase shift. So phase shift is basically saying moving left and right, but in the case of a sine and cosine wave or anything with a trig function, we call that phase shift instead of saying going left or right. But it's the same idea. In this case, phase shift is C over B, where C over B greater than 0, we're going to go to the left. Okay, greater than 0 meaning like if you see the equation bx plus c. So same idea as before. If you see a plus, you're going to go to the left. If you see a minus, you go to the right. So it's the same thing. C over b less than 0, that means when it's a negative number, it goes to the right. And then d is the up and down, just like k before. So if d is greater than 0, it's going to go up. D is less than 0, it's going to go down. If you're not sure how to find the amplitude from a graph, what you can do is take the total height of the graph, when in this case is 2 units, and then divide by 2. That will also give you the amplitude. So that's another way to find the amplitude. All right, so let's go ahead and take a look at an example. Determine the amplitude of the sinusoid and determine the transformation. All right, so let's take a look at A. If we just want to find the amplitude, that has to do with A, or absolute value of A, so that is 3. So the amplitude is 3. It's going to go up 3, down 3 in its total height. Determine the transformation. The only thing that's happening to this cosine function is the -3 that's multiplied. So we know this is vertical stretch of 3, and then reflect x-axis. All right, let's go ahead and have you try this one. So first, when you look at this graph, you need to first ask yourself, what graph is this? Do you think this is a cosine, or do you think this is a sine? Of course, it can be both, but you want to just make it easier for yourself and pick the easiest or the closest shape of the sinusoid. And then you ask yourself, okay, what transformation did I make to this graph? So go ahead and try it, and then we'll check the answer together. All right, so the first thing is the amplitude is 3. That's the first question. So what you can do again is you take the whole overall height, which is 6, divide by 2. So the answer is 3. Next, I'm going to say the closest shape to this is a cosine graph. Of course, I can say this is also a sine graph, but then I really don't want to deal with phase shift here. So I'm going to call this a cosine graph. And then if I kind of think about the cosine graph is going to start at the top 1 here, and then kind of goes down like that. So there's something that happened to this cosine graph that made it that shape. First, I noticed that this center moved, right? It was the center, kind of like the center of the graph going up and down, was kind of supposed to be at 0, but you can see that this has moved to around here, which is 1. So I know that this graph has moved up 1. And then knowing that this amplitude is 3, I know that there is a vertical stretch of 3. And that's it. All right, now let's talk about period. So we said that the period is the length for one cycle of the graph, or how long it takes before this wave repeats itself. So the fastest way to recognize that is if you pick from the maximum to maximum, or you can pick from the minimum to minimum. Okay, so let's try an example. So figure out the period of the sinusoid and then determine the transformation. All right, let's take a look at A. Period of the function, if you remember the formula from the previous page, is 2 pi over absolute value b. Now, b, remember I said, is the number that is multiplied to x. So what number is being multiplied to x? Well, if I were to rewrite this question with that x over 3 changed to something multiplied to x, I would have to write it as 1/3 times x. Therefore, b is 1/3. So this is 2 pi over absolute value of 1/3. All right, let's go ahead and simplify this. So this is 2 pi times the reciprocal, which is 3. So then this period is 6 pi. So that means it takes 6 pi long for it to repeat itself. Now let's take a look at transformation. So I see that -2 means reflect x-axis. Vertical stretch 2. And then you can see that there is this 3. inside the function and in the denominator. So that tells me that this is a horizontal something, horizontal stretch or compress. And if you recall that horizontal something has to be in the denominator, which it is. And it is a number that is bigger than 1. So this is a horizontal stretch of 3. All right. Let's skip this one here, B, because that's the same graph as before. Okay, so let's talk about horizontal stretch or shrink. So just to remind you, so if it's a stretch, then that number has to be inside the function in the denominator, and that number is greater than 1. If it's shrink, then this number is inside the function in the denominator, and that number is between 0 and 1. Okay, and make sure you put the absolute value sign around it. So we're only looking at the number itself and not the sign. All right, frequency. So frequency is the number of completed cycle or complete cycle within a certain interval. So like within 2 pi, how many times did this wave show up? Is it one time? Is it half a time? That kind of stuff. All right, so let's try this one. Find the frequency of the sinusoid, determine the transformation. So again, I will show you how to do one, and then you can do the other one. So frequency is 1 over period. Okay, and then remember the period formula is 2 pi over b, or 2 pi over absolute value b. So this is the reciprocal of that, so it's absolute value b over 2 pi. All right, what number is b? B is the number that's being multiplied to x, which in this case is 2 over 3, because it's 2 over 3 times x. Okay, so this is going to be 2 over 3 over 2 pi. Okay, if you're not really certain how to simplify this, again, you can multiply by the reciprocal of 2 pi. So multiply by reciprocal of 2 pi, which is 1 over 2 pi. So 1 over 3 pi. So this is the frequency. And then determine the transformation. All right, determine transformation. So we know that this is 4 sine, and then we have a 2 over 3 times x. Now this 2 over 3, because it's inside the function, we know it has to do with something horizontal stretch or shrink, but this number needs to be in the denominator. So how do we put this 2/3 in the denominator? Well, we had to put the reciprocal in the denominator, which is 3/2. So 3/2 goes inside the denominator. Now let's look at the transformation. This 4 means vertical stretch 4. Maybe I should say of 4, or factor of 4. 3/2 means this is a horizontal stretch of 3/2. Those are the only two transformation for this graph. All right, let's go ahead and have you pause the video and try this one. All right, go ahead and check your answer. All right, phase shift. Phase shift is the horizontal translation of the graph. All right, so let's look at this question. Write the cosine function as a phase shift of the sine function. Right, cosine function as a phase shift of the sine function. Well, let's take a look at the two graphs from the very beginning of this chapter. So we know the graphs looks like this, where the sine graph was something like this, and the cosine graph was something like this. All right, so we can see that so phase shift is basically saying, how much are they offset by? So if we want to write the cosine function as the phase shift of sine function, what that means is cosine function, we want cosine x to be sine function with some kind of movement left and right. So how do we shift the sine graph, which in this case is black? How do we move the sine graph so we can push it to show up as the cosine graph? Well, this is pretty simple. You can see that this sine graph here, if I push it to the left this much, then they would lie on top, the graphs would lie on top of each other. And how much do I have to move? That is pi over 2 to the what direction? To the left. So I need to push this to the left. So that means when I write in the equation, I need to put a minus pi over 2. I'm sorry, plus pi over 2. So I'm pushing the sine graph to the left pi over 2. Is that the only way I can get to this cosine graph? Not at all, right? I can actually push it to the right. If I take this point, or even this peak, right, this maximum, and then if I push it this way to the right by this much, I would have the cosine graph, but how much is that? Well, this part at this location that it's pi over 2, this much is pi plus another pi over 2, so this is 3 pi over 2. So 3 pi over 2 to the right. So cosine x is equal to sine graph, and then if I push it to the right, 3 pi over 2, I would have the graph. So you can graph it on your graphing calculator and just to double check that this is true. Okay, so let's have you practice. Write the sine function as a phase shift of the cosine function. So sine x is equal to cosine, and then what do you do to it to make it look like what do you do to the cosine function to make it look like sine? So go ahead and pause the video and give this a try. All right, so same idea as before, minus pi over 2, or you can also say cosine x plus 3 pi over 2. Okay, let's really quickly review graphing. So you can read this direction if you want, but I'll just talk about it. So it's the same idea. I mean, we learned this last year, so it should be pretty fast. All right, what you want to do is first, you always want to figure out the amplitude, which is the absolute value of A. In this case, is 1. Next, you want to find B because B is going to help you figure out the period, which is 2 pi over B. In this case, would be 2 pi. So every 2 pi, it's going to repeat itself. So what you're going to do is if there is no shift at all, meaning there is no phase shift, there is no vertical shift, then it's always, for sine, it's going to start at 0, 0. What we're going to do next is graph one period, or make a mark at one period, which is 2 pi in this case. Halfway, make a mark halfway through it, and then half of that, and half of that. So we're dividing it into 4 equal quarters. Okay, we're doing the same thing on the left. So 1 period, half period, quarter period. Next, we're going to mark out the amplitude. So highest point, which is +1, lowest point, which is -1. And then what we're going to do is remember sine graphs goes up, down, down, up. What does that mean? So starting at the starting point, up. So every quarter mark has a point. Up, down, down, up. On the left, of course, you're going to have to go backwards. So down, up, down. Okay, you must make these marks before you start connecting the dots, or else it's not going to be accurate. So make sure your lines are curvy and not angular like this. Okay, so this is the sine graph. Let's practice the cosine graph. Cosine graph is pretty much the same as you have just practiced, where we realize it's just a phase shift of the sine graph. So it should be pretty easy. Amplitude is 1, b is 1, period in this case is again 2 pi over b, which is 2 pi. All right, so we're going to mark out. So the starting point is 0, but not 0, 0. But it really doesn't matter at this point. We're just kind of making those quarter marks. Okay, so make a mark at 0, 1 period, half period, quarter period. Same thing on the left. And then make marks at the amplitudes. For cosine graph, it starts on the top, and then we're going to go down, down, up, up. So it first goes down, then down, up, up. Connect them. Do the same on the left. Down, down, up, up. Connect the dots. That's it. So this is a very quick review of sine and cosine. Let's go ahead and have you practice. Let's practice B, since that's a little bit harder. Okay, so again, you're going to find amplitude, B, which is going to help you figure out the period. Draw out 1 period, half period, quarter periods, make marks at the amplitudes, and then remember this is a sine graph, so it starts at 0 and goes up, down, down, up, and then connect the dots. All right, go ahead and pause the video, give this a try. All right, please go ahead and check your answer. All right, let's try another one. This one's a little bit different. 3 cosine pi x. Pause the video, give this a try. Okay, so I only drew 2 periods of it, but here's how you do it. So the amplitude is 3, b is pi, which means period is 2 pi over pi. Well, what does that mean? Well, this 2 means 2 radians. Okay, and then we just do the same as before with the cosine graph.